Welcome to week 8 of remote learning. Our topic this week is a linear functions review. Your homework is a Desmos activity, similar to what you've done the previous weeks. And just like every week, my office hours are, that says Tuesday, but they're Monday through Friday this week from 1 to 2. But again, feel free to reach out to me if you would like to set up a Google Meet. For the first example, it asks us to write the equation for the linear function from the given information. In this first example, we're given a table and you're asked to use the forms y equals mx plus b, which is your slope-intercept form, or your y equals m parentheses x minus x1 plus y1, which is called your point-slope form. So for either one of these equations, you're going to need the slope. And again, I've started off with my favorite, the table. So we want to look at our change in x over our change in y. If you notice, this table is labeled x and g of x, but remember g of x is the same thing as y. And so if we want to look at the change, again, it doesn't matter which two values in the table you use. I'm just going to use the top two. So from 9 to 7, that is a decrease of 2. So negative 2. And then if we look at our x values, so this is maybe a little bit harder to think about, but to go from negative 6 to negative 3, that is an increase of 3. So my slope, my change in y over my change in x, would be a negative 2 over 3. For this one, to me, it's easier to do point-slope form. So that's the one I'm going to do first. And so I have y equals, and we just found our slope was negative 2/3 x, and then we can pick any point we want to. I'm just going to use this last one down here at the bottom, 3, 3. So x, remember that means the opposite of x1. And so this is my x1 and my y1. So x minus 3, so it's the opposite, and then a plus 3. If you wanted to write it in slope-intercept form, I'll do this one in green. Again, that is y equals mx plus b. We already know that y is, or excuse me, the slope is negative 2/3. I'm going to use a capital B because my B's sometimes look like 6s. And then I'm going to use the same point that we did before. So y is 3, and x is also 3. And so if you distribute your negative 2/3 times 3, that just gives you negative 2. And then if you take the negative 2 over, b is equal to 5. So in slope-intercept form, we would have y equals negative 2/3 x plus 5. Another way to come up with that equation is we could distribute the point-slope form in purple and then simplify, and you would come up with the exact same thing. So again, looking at a table, first find your slope, your change in y over your change in x, and then personal preference, depending upon how you would like to write your equation. All right, in the second example, again, we can write the equation in point slope and in slope intercept, but we need to find what that slope is. And so you need to start off finding two good points. And I would say that this point right here is a good point at negative 2. So that would be 0, negative 2, and this other point here. And then if we just count our rise over our run, another way to think about slope from a graph. And so we would rise, remember you have to be careful with your scale here. So that's 2, 4, 6. So we're rising 6 units. And we are running, again, pay attention to your scale, that's 2. So my slope is 3. Also, from this graph, we can see our y-intercept here is negative 2. And so if we want to write it in slope-intercept form, it's very easy to do. So it's 3 x, because that's what we came up with for our slope, and then our y-intercept is a -2. Again, if you would prefer to write it in point slope, y equals, again, our slope is 3, x, and then we can use any point we want to. I think I'll use the point here, which was 2, 4. And so x minus 2 and a plus 4. Again, that is our point slope form, which I'll write underneath. Again, these equations look very different, but if you distribute the purple, distribute the 3, and then simplify, you will come up with the same equation. All right, in this third example, I've given you 2 points. And again, we want to write the equation of the line. I don't have graph paper for this one. Also, there's a decimal, so I don't think graphing would be very beneficial. So I'm going to make a table out of these. So I have -11, 4.75, and 12, -1. And so if we look at our change here, our y values are getting smaller, and that would be by -5.75. And then we look at our x values, those are getting larger, and that would be by 23. So my slope, my change in y over my change in x, would be -5.75 over 23. That's kind of a nasty number. So if we simplify that, it gives us a -0.25, or if you prefer fractions, you could write that as a -1/4. And I think for this one, I'm not even going to bother with slope-intercept form. We're just going to stick with point slope. Again, you can use either point you want to. I think I'll just use the second one because it doesn't have any decimals in it. So again, y equals m parentheses x minus x1 plus y1. Again, this is our x1 and our y1. So y equals -1/4. X, the opposite of x1, would give me a -12. And then y1 is a -1. Again, you could use slope-intercept form as well, but this one is a lot less work. All right, here's another example with 2 points. So again, starting off with my table, 0, 9, and 1794. Both of these are increasing. And so to go from 9 to 94 is an increase of 85. And then from 0 to 17 is an increase of 17. So my slope, my change in y over my change in x, is 85 over 17. And then once again, we can simplify that, and that just gives us 5. And then one thing you may not have realized in this example, this point 0, 9, that is actually our y-intercept. And so this one is pretty easy to write it in slope-intercept form because we just figured out the slope was 5 and the y-intercept is 9. Again, if you prefer point slope, we can use that as well. Again, you can use either point. Our slope is 5, x, opposite of x1, so 17, and then a plus 94, or the other point, 5, and technically it's x minus 0 plus 9, which simplifies to just 5x plus 9, which is what we had in red. Again, the equations look very different, but by distributing and simplifying, you will see that they are all equivalent. All right, so that went through 4 different examples of writing equations of lines. First example from a table, second example from a graph, and then the third and fourth examples gave you 2 points, which I created a table from. So now we're going to transition to graphing. These first two examples from graphing, they're both in slope-intercept form. Remember that's y equals mx plus b. Your m is your slope, and the b is the y-intercept. So for this first graph, y equals 3x minus 1. Again, we always start with the y-intercept. So I'm going to put that point at -1. And then my slope is 3, but remember you can call that 3 over 1. So we can go up 1, 2, 3, and over 1. So up 3 and over 1. And so now I have my 2 points, and I will do my best to draw a line. Notice your slope is positive and your line is going up the hill. All right, for our second example, our y-intercept this time is a positive 2. So we start there. And this time our slope is negative, and it's already a fraction, so it's negative 2/3. So I'm going to go down 2 and to the right 3 units. And then I can draw my line. Notice the line is going down the hill because we have a negative slope. All right, so the next two examples are what we call special cases. These are examples of when we have vertical and horizontal lines. So for the first one, we have y equals -3. So we're going to go onto the y-axis, and we'll go to -3, which would be here. And then you're going to draw a horizontal line through y equals -3. So when it's y equals, it's a horizontal line. Also, you can think of that as y equals 0x minus 3. So you have a slope of 0, so there's no rise, it only runs, because that can be 0 over any number. For example 4, we have x equals. This is going to be a vertical line. So you're going to go on your x-axis to -3, and then we're going to draw a vertical line through x equals -3. And this one does not have slope, so this is called no slope, or sometimes it's called undefined slope. So again, two special cases. All right, so now what I want you to do is on your own paper, try to graph these two examples. Again, remember you start with the y-intercept and then use your slope, and if you need to make it into a fraction, feel free to. So at this time, if you'll pause the video, work these two out on your own paper, and then when you're ready to check your answers, press play. Okay, if you're not ready to continue, again, please press pause, but I'm going to start working through these. For example 1, your y-intercept is a positive 3. So I'm going to go to 3 on the y-axis. And then my slope, I can make this a -2 over 1. So I'm going to go down 2 and over 1. And then I can draw my line. All right, for the second equation, that one looks a little weird. That decimal I'm not a fan of, but I know that 0.25 is a quarter, so that's 1/4 of a dollar. So I'm going to write that as 1/4 x minus 3. Again, we look at the -3 as our y-intercept. So I'll start there, and then I'll have my slope. This time my slope is positive, so I'm going to go up 1 and over 4, and then I will draw a line through those 2 points. So hopefully you got those right. Again, if you have questions, send me an email, and I'm happy to do some more examples via Google Meet if you need it. All right, so here are two special cases. I want you to try to graph these, y equals 2 and x equals 5. So again, if you'll pause the video at this time, work these two, and then when you're ready to check your answers, press play again. Okay, I'm going to go through these two. Again, if you have not finished, please press pause. Y equals 2, remember, is a horizontal line. Again, we can write that as y equals 0x plus 2. So we're going to get that y-intercept of 2. And then since our slope is 0, we don't rise, we only run. So we draw a horizontal line through that. All right, x equals 5 is going to be a vertical line. Again, this is the one where we don't have slope. So on the x-axis, we're going to count to 5. And then we're going to draw a vertical line through x equals 5. So again, just special cases. All right. All right, so now it's time for you to do some practice. Again, you will need to pause the video. I think there's 4 different slides. All right, so this one, instead of you graphing the lines are already graphed for you. And you have a choice. You don't have to do both. You can write the equation in slope-intercept form or point-slope form. So again, if you will pause the video, write down your answers to these two, and then when you're ready, press play to check your answers. All right, I'm going to go through the answers. Again, if you have not pressed pause and you need some more time, please do so. So for this first example, I can see my y-intercept right here. That's -1. And then I need to find my slope. And so this looks like an easy point to read. So I can see that goes up 2 and over 1. So my slope would be 2 over 1, or just 2. So y equals mx plus b. My slope was 2, and my y-intercept was -1. Again, no need to write point-slope form. Be careful with part B. Pay attention to the scale. Notice that this point right here is at 1, and this is a horizontal line, so I know it's going to be a y equals. Again, it's a horizontal line, so we don't have any slope. Our slope is 0, so I could write that as 0x plus 1, but most of you simply probably wrote just y equals 1, which is what I would do. But both of those would be correct. All right, so for question 2, it says write the equation of the linear function that passes through these 2 points, 9, 8, and -1, 5. And again, you have a choice of which form to write your answer. So at this time, press pause, work through this, and when you're ready to check your answer, press play. Okay, I'm going to work through these. Again, if you need more time, please press pause. I'm going to use a table. So 9, 8, and -1, 5. Again, we're looking at the change. So to go from 8 to 5, you are getting smaller, you're decreasing, so that's a -3. And then to go from 9 to -1, you're also decreasing. You're decreasing by 10, so -10. So my slope, my change in y over my change in x, is a -3 divided by a -10. And a negative divided by negative is a positive, so we can just say our slope is 3/10. Then I could use either point that I wanted. I'm going to use 9, 8. And I'm just going to go with point slope form because that's the least amount of work. So again, as a reminder, here is point slope form, y equals m parentheses x minus x1 plus y1. So our slope we came up with was 3/10. And then again, this is the opposite of x1, so that would be -9. And then y1 would be 8. Or if you use the other point, you would have x, and then it's the opposite of -1, so that would be a +1, and then a +5. So either one of those would have worked. You can use slope-intercept form. If you want to check your answer for that one, you could just distribute, or again, feel free to email me if you have questions on this one. All right, question number 3. You have a table this time, and we want you to write the equation of the line. Again, your choice of slope-intercept or point-slope form. So press pause, work through this, and then when you're ready to check your answer, press play. Okay, I'm going to start working through this one. So again, if you need more time, feel free to press pause. Again, this is a table. This is kind of a horizontal table, which I'm not a huge fan of. Again, h of x is the same thing as y. So we're going to look at our change in y over our change in x. And I think I'm going to use these two. So to go from 6 to 3, we are subtracting 3. And to go from 5 to 7, we are adding 2. Again, I could have used any 2 points. So my slope, my change in y over my change in x. The y's were decreasing by 3, while the x's were increasing by 2. And then I think, again, I'm going to use point-slope form. So my slope is -3/2. And then I can use any point that I want. I think I'm going to use this one, 3, 9. So that's my x1 and my y1. So x opposite of x1 would be a -3, and then my y1 would be a 9. Again, there's lots of different equations we could write depending upon which of the points you chose. You could also plug in and use slope-intercept form as well. And our last example for today, I want you to graph this linear function. So again, on your own paper, sketch it. If you have graph paper, that's great. If not, just make a sketch. And then when you're ready, press play to check your answer. All right, I'm going to go through this. Again, this is in slope-intercept form. That's our y equals mx plus b. So our b is our -1. And so I'm going to start with -1. And then my slope is my -3/5. So I'm going to go down 3 and over 5. And then I can draw my line. And we see that negative slope where we went down 3 and over 5, starting with the y-intercept of -1. All right, hopefully that was a good review of linear functions today. We did another Desmos activity for you just to kind of make sure that you understand this. So please make sure that you go in and do that. I will be logging into Desmos to check your work and see how you guys are doing. And the code this week is A7PCMC. Hope you guys have a great week. Take care.